Hello everyone, my name is Sayed. Today we are going to discuss about chapter 10, that's a cube. So let's see what chapter objectives we have in this one. Okay. First, the overview of the cube. What is a cube? Then key features of the cube gateway, means what different features of the functionality it supports. The next, cube deployment models. Yes, we have three different types of deployment models. Then where we can use the cube, means in exactly which scenario, which topology we can able to be use this cube. Then media flows on the cube. Okay, media flows means whenever you want to be communicate, we use two protocols. One is the signaling protocol and another one is the streaming protocols. So here, how exactly it can be flow, the signaling and streaming protocol, that we'll be discussing under the media flows on the cube. Then DTMF supports in the cube. Yes, DTMF is required, a dual tone multi-frequency. The what different types of DTMF it will be support when you use the same protocol or the different protocol. Okay. Then configuring this is the wrong one. MGCP gateway. It's not an MGCP gateway. Okay. So let me change. This is cube. Okay. Configuring the cube. Finally, the configuration, we had to do it from the scratch. I'm going to do, even the configuration has to be done on the call manager. But generally, the cube, which is only related to the voice gateway, which is not related to any call manager or the provider here. But in a full-fledged, I'm going to configure everywhere on the CUCM, gateway, provider, every configuration I'm going to be do it here, this one. So let's begin about the overview of the cube, what exactly the cube, okay, why we require and which device we call it as a cube here. So before we get into the bullet points, what exactly the points we are having, so I'm going to be explain you that one, how the topology comes, okay, for which device we can be call it as a cube gateway or cube device. Okay, so for an example, I'm having a topology. So this is my CUCM. Then the phones are registered here. And it's having the internal extension. Then it's connected to the gateway. Then this gateway, it's connected to ITSP. Okay, so now between the call manager to the gateway, to communicate, we use IP address, right? And again, to communicate from the gateway to ITSP also, we are going to use IP address here. When both the end, one end, it's internal, gateway to call manager, gateway to provider. It can be any provider. You have a PSTN, you have, or normal internet ISP, you are connecting this one. So both the end, you have IP to IP communication. When you have a IP to IP communication, then this gateway, we call it as queue. Or also we can call it as SBC. Okay, cube stands for Cisco Unified Border Element. SBC, Session Border Controller. So within a Cisco realm, we call it this as a queue, but in the industry, it's called as a SBC, Session Border Controller. Other vendor, they call it as a SBC, but in Cisco, we call it as a queue, but both are same. So that is what here this one. Okay. When you have IP to IP communication, for this router, the voice gateway, whatever we have, it's called queue here, this one. Now, to communicate from the CUCM to the gateway or the queue, you require the protocol, right, to carry your voice information. Which protocol you can be using here? Okay. You can use SIP protocol. Yeah. See, whenever you are calling, the call is coming and call is terminating on the gateway here. Then from the gateway to the provider, another call leg is going to generate. There are two call legs comes. One call leg from the call manager to the gateway and vice versa. And another call leg from the gateway to provider and vice versa. It can be from the provider to gateway or gateway to provider. gateway to CUCM, CUCM to gateway. This is how the call legs it will be generating here, this one. Now, I'm using a SIP protocol to communicate between the CUCM to the gateway. Then what about gateway to ITSP? Here also we require the protocol. Okay, again we can use SIP protocol. So when you are using the Cube router, it supports two protocols, SIP and H.323. So for example, see both the end I can use SIP or I can use H.323, H.323. Both the end I can use H.323. Or I can use H.323 one end between the CUCM to Cube, but between the Cube to ITSP I can use SIP protocol. Or I can use SIP H.323. However you want. Okay, which protocol, which end you want, you can. Both the end same protocol, both the end different protocol you can use. Still it works. That is what the Cube. Cube supports two protocols, H.323 and SIP, and this protocol you can implement anywhere. Same protocol you can implement or different protocol you can implement anywhere, any protocol you can implement that one. So that is about the Cube, how exactly it works. Okay. Now we have already the voice gateway. What is the use of this Cube? One, the Cube, what happened here, this one, it worked like a proxy. How? Because the complete internal, whatever the topology I'm having, it's going to hide, right? Whenever it's sending the invite message to the ITSP, suppose if I'm using the SIP protocol, it will be sending the information invite to this one. It will be adding the source as this one and destination as this one. But it will be not providing the internal information, right? When it is not providing the internal information, it will be acting as what? Proxy. But actually it's not a proxy. It will be act as a proxy or intermediate server. Okay. You will get more security here in this one. When you use the Cube, what happened? So if anybody trying to get your information, attack your information, what happened? Okay, internal information is going to hide.
But in normal, if it is not a queue, but that time also we get two callbacks and the call will be terminated on the router one.
That's what IP to IP, it's automatically you have to configure that as a queue. Another end, if it is a PSTN, then that's not an IP address, right? IP to IP, that's a different.
Coming to security wise, I'm telling you. At that time, we won't get
that's what
security.
Both the end IP to IP communication, automatically this router will act as a queue.
Yes, sir, I got the point. It will act as a queue. But I'm telling you.
Okay, give me the example scenario where other means void.
Other means now it is PSTN. At that time also.
So then PSTN, that is not a cube, right?
It is not a cube. I'm asking about the security. How will the security?
The security will be there, but again for the PSTN, you are not using an IP address.
You are not using that. They will be having a less security compared to this cube or whatever.
No, it's not like less security, more security. PSTN physically you are terminating. Any information you want to be gathered, you require an IP address. Without an IP address, how you can gather the information? How you can attack the network in the PSTN? Okay, so what happened here? More security we get it, and it will be hiding the internal topology information and NAT, everything you can implement still. All the protocol it supports, TCP protocol, UDP protocol, all the codec, all the DTMF, NAT you want to be implement, NAT also it will be support, secure communication can be enabled, everything we can be configured, okay, on the Cube here, this one. And this is the very famous deployment we have, because you go to any organization, yes, many organizations using a different topology, different protocol, but many in our organization, they use the Cube router because always they connect the ITSP with the SIP trunk. Okay, always they go with the SIP trunk. So when they are going with the SIP trunk, obviously it will be act as a Cube router. So that's how. This is the advantages and how exactly the Cube, which device we call it as a Cube. The router itself will act as a Cube here, this one. But few extra configuration we have. When configuring SIP protocol, the same command we have some extra configuration we get it, and many information you can be manipulate here in the Cube also here, this one. Okay, any information, any profile information, SIP profile, where the header information you want to be manipulate, That can be manipulated here in this one cube. Okay, there are many things comes in this one that we will look into the configuration part, what exactly that one and why we have to be manipulated, in which scenario we have to be manipulated. Suppose you want to be manipulate anything, okay, how exactly you have to be manipulate this one. So for this router, we call it as a cube. When we call it, and both the end you have the IP to IP communication, then automatically that router we can be configured as a cube. Cisco call as an IP to IP gateway and industry call as a SBC, session border controller. Okay. It's a gateway that allow both inbound and outbound calls of VoIP types, right? It will be allow both inbound and outbound because both the end we are using IP address, then it should be VoIP, right? The dial pair we have to be create. What type of dial pair? VoIP dial pair we have to be create here. It's a border between two networks, right? So one LAN network, internal network I'm having, one is the public network I'm having this one. I want to communicate from my internal network to the public network, it will be acting as a border here. Okay. Then protocol interoperability means it is having the ability to work with the two different protocols. So as I discussed, okay. So one end you can use SIP protocol, another end you can use the H.323 protocol. Still it will be going to be support and it will be work. For that we call protocol interoperability. Next, terminates and originates signals and media stream between H.323 to H.323, H.323 to SIP to SIP to H.323. Next, media networking, DTMF it supports, fax it supports, modem, codec, transcoding. Means when you are using a cube router, how exactly the voice gateway it functions, what different feature services it supports. The same feature services it supports on the cube also here. So you want to implement DTMF, you want to implement any fax dial pair, any modem or any codec you want to be configured or transcoding you want to be configured, still the cube router is going to be support all this type of media networking features. Address and port translation, privacy and topology heading. That is what address and port translation, where we can manipulate the complete information. Okay. By default, it's not going to manipulate. You know the digit manipulation, right? Number is going to masking, number is going to manipulate. But here, the complete header information itself we can manipulate. For example, internal user is calling Ishapa. Okay, Ishapa is calling, but in the log when we can see Ishapa is coming, but we can manipulate that one Ishapa to some other name. Okay, Girish. Okay, now it will be display Girish is calling, but actually is calling Ishapa that one. Any information, the header information of the SIP protocol you want to be manipulate, you can be manipulate that one. Why you have to manipulate? For security reasons. Okay, centralized bandwidth management it supports. Okay, bandwidth management centrally we can be managed. So this is about the overview of the cube. Next, the features we have protocol, H.323 of SIP. Okay, and networking hiding. You can hide the IP address, topology, boundary, user information, agent information, every information. Call admission control, that is for the bandwidth management. It supports the call admission control protocol between H.323, H.323, SIP to SIP, SIP to H.323, H.323 to SIP. It will be supporting media, RTP, RTCP. Okay, media modes, flow through, flow around. I'll come back on this one. What is this flow through and flow around? Okay, video codec. Head 261, head 263, head 264. These are the different codec it supports for the video call. It supports TCP, UDP, TCP, UDP, both protocol it supports. DTMF, all this type of DTMF it supports. Fax protocol it supports. Media supports. Any supplementary services. Okay. NAT you want to implement, it supports NAT also. Voice quality, QoS you want to be implement. Every information it will be support as like a voice gateway. Okay. All this we can implement on the voice gateway, normal voice gateway. But the same features, it also supports under the queue. Okay. Any number translation you want to manipulate or codecs. Okay. Then security, transcoding, AAA, we can be configured, billing, voice media application. Every feature of the voice gateway, it supports under the queue. Getting next is the cube deployment model. There are three different types of deployment model. We have centralized, we have distributed, we have hybrid, we have this one. And the centralized is this is the very famous deployment model. Okay, already many times in the class we have discussed about this about the centralized deployment. Consider this is my headquarters. This is in Bangalore. Okay, then I am having a branch offices. Okay, branch offices I am having here this one. Okay, Chennai, Pune, Hyderabad, Noida, I'm having here this one. Okay, now what I am doing, all these location branch offices, I'm not going to install the voice gateway locally. We have only internet. We have only what? Internet we have this one. And to communicate from the headquarter to the branch office, we are using the SD-WAN. But here in the topology, you can see MPLS. Okay, before to the SD-WAN, MPLS was there. Still now also few organizations, they are using an MPLS. But now the latest technology is SD-WAN. To communicate from the two branches, SD-WAN we can use. Okay. Secure communication, tunnel it will be established. All the traffic will be flow. Any kind of the traffic will be flow between the branch to headquarter, branch office to branch office through that tunnel. Okay. Now we don't have the, now for to implement that MPLS or SD-WAN, yes, MPLS, we have separate devices for that. Okay. For an example, SD-WAN, separate devices we have in the Cisco. It's called Cisco Viptela. Viptela for the SD-WAN. And we have a Silver Peak. That is a different vendor. So they will be providing the. See, there are many vendors. Fortinet we have, Checkpoint we have, Palo Alto we have, Silver Peak we have, Cisco we have. All these vendors they will be providing the SD-WAN technology. So now every organization to communicate from the branch office to branch or branch to headquarter or vice versa, they use this SD-WAN technology. Okay. Now I'm having router only on my headquarter. Means on Hyderabad, Chennai, Pune, Noida, I don't have the Cisco router or the gateway I don't have. I have a router only on Bangalore. Okay. Now I'm taking the connection to the Hyderabad. Hyderabad SIP trunk I am taking. Okay. Now the SIP trunk, I have to update to the provider that one. Okay. I have to provide only the IP address to the provider. Okay. Where exactly the call has to be terminated. Whenever I am purchasing the SIP trunk from the provider, I have to update the provider where exactly my call has to be terminated. In that scenario, I'm going to provide the IP address of my Bangalore. So there it should be public IP address, not in a private IP address. It should be public IP address. That public is so terminating your SIP trunk over the public IP. This is how it works. So then what happened here? This one, whenever if anybody calls to Hyderabad, actually call comes to Bangalore. From the provider, we have given the Bangalore IP address, right? The public IP address we have given. The call comes. Actually, it's not like a Bangalore IP address. IP address you can be assigned the public anywhere, but that IP address we have assigned in the Bangalore gateway. So it will be coming to the gateway here. It will be checking, okay, internally. Then it will be connecting to the call manager. From the call manager, it comes to the this location IP phones. So all it will be traffic flowing through the SD-WAN internally. So this is how, this is the actually centralized deployment, and this is the very famous deployment. Many organizations, they use this centralized deployment. When they are using this centralized deployment, where the branch office, very small office we have, only 30, 40, 50 phones we have this one, or 50 phones we have, or 100 phones we have this one. So not required to be installed one dedicated gateway, because again, one single gateway dedicated you want to be installed, it's more expensive actually. So now the latest 4000 series, the basic model, if you go, so minimum it costs 3 to 4 lakh rupees one single router. For example, 4 locations, okay, on average, if I'm taking the 4 lakhs for one router, 4 location, how much it costs? 16 lakhs. Instead of that one, install 2 routers on the headquarter and terminate all the costs in the headquarter. Then why we have to be so? Because already we have a SD-WAN technology. Then easily we can communicate, right? So that's how, okay, this SIP trunk, the centralized cube deployment comes on that.
Sorry,
Okay.
India try rules, right?
I'll come back on that.
Yeah, I said.
You got it, this one?
Yeah.
Okay. But in India, it's not possible because we have a try rule. What is the try rule here?
Yeah.
Say in India, it's not possible to terminate the SIP trunk over the public IP address. something you have given a public IP address, you want to be terminate, it's not possible. Okay. And here what happened this one in the centralized. So they will be just we have to provide the IP address to the provider. They'll be sending the call to that IP address. But in India, how exactly we have physically they'll be terminating the connection. They'll be grabbing a cable from the provider and it will be connecting on the router physically, like how we are connecting the PRI connection. SIP trunk also will be connecting same way. The difference in the PRI will be connecting on the even interface. Right? But here, the Ethernet port we are connecting. Whatever the cable we are grabbing, we are connecting on the Ethernet cable. Then IP address we are assigning. That is the difference. In the PSTN, we don't have an IP address, but that's terminating on the even interface. But here it's terminating on the gigabit Ethernet port, but we are assigning the IP address. So technically it's called PRI SIP trunk. It's not actually the SIP trunk, but it's actually the SIP trunk is you have to terminate that SIP connection over the public IP address. So you have to be check it out. Few countries it will not allow. So then always you have to go with the PRI SIP trunk. But in India we have PRI SIP trunk. So in India it's not possible to implement the centralized deployment because physically it has to terminate. Okay, then distributed similarly. Every location one gateway we have installed and it will be terminating on the same local gateway. Then hybrid we have. Hybrid means few location, we can go with the centralized, few location, we can go with the distributed, we can go. If you talk about my company, we have the same way. Few location, what we have done the centralized. Few location, what we have done, so distributed we have done. Why? Because of the tri rule, the countries like Dubai, India, Singapore, Hong Kong, Tokyo, Japan, all this is not possible to do the SIP trunk or the public IP address. Physically, it has to be terminated on this one. Got it? So that's how the cube deployment model comes here. There are three types of deployment, okay, that we have already discussed: centralized, distributed, and hybrid. Okay, where exactly we can use the cube? Same thing. CUCM to gateway, gateway to provider, CUCM. Okay. See, anywhere between two cluster you have, but in between router you are using. Okay. We can use, for example, cube we can use to SIP trunk for as a PSTN access, in the enterprise network, or business to business telepresence for H.323 video calls. You want to be communicate, then also we can use the cube protocol. Media flows of the cube. Again, we have three types of media flows. This is the, you can see the diagram. This is for the media flow through and media flow around. We have this one. Okay. If you remember, whenever we make a call, we use two protocols, right? One is the signaling protocol, another one is the streaming protocol. Signaling protocols, which are the signaling protocols? CB, SIP, MGCP, and H.323. We have this one. Next, which is the streaming protocol? RTP. Yeah, this one. So if you remember, RTP, it will be flow directly from one point to another point. That means you have two phones. Both the phones are registered in the call manager. Whenever you are making a call from phone 1 to phone 2, call has to go from the call manager. Once they answer the call, RTP will establish. Now, RTP is not required to flow via call manager. RTP can be bridged between this IP port. Because for the RTP, it required only IP address and the port numbers. Call manager information is not required. So that's how RTP will be flow here, this one. So now, suppose you are using a gateway, how exactly your RTP has to be flow? That is what your media flow describes here. You got it or not this point? In the beginning, I have already explained about this one, about the RTP actually. See, for example, I'm having a CUCM, okay, and two IP phones I'm having connected. It's extension 1001, 1002. I'm calling from 1001 to 1002. When I'm calling, what happened? It will be signaling to CUCM. Then CUCM will be checking, oh, it's internal. It will be sending the ringing signal here. Till here, it's a signaling protocol. Then after user is answering the call. When the user is answering call, RTP comes between these two phones. Okay. Now RTP, how exactly it flows? RTP from this IP phone switch to IP phone. It will it will not go to the call manager. Why? Because for the RTP, it required only source destination IP address and the port numbers it required. If it is having, that's enough to be established the bridge. Now already CUCM is providing the source and destination IP address and the port number. So it will not flow the RTP to the CUCM here. So the same way, now if you are using the router, how exactly your RTP has to be flow? That's what the media flow on the cube describes. Okay, so Cube is a signaling proxy and it is also process all signaling messages regarding the setup of media channel. This enables the Cisco Cube to affect the flow of the media traffic. Okay, we have a media flow through. What exactly this? See, I have two different clusters. Cluster 1 and cluster 2. This is my source phone, this is my destination phone. So I'm making a call. When I'm making a call, what happened? First, it goes to the CUCM. From the CUCM, it will be checking what type of number. It's an external number. Okay, it will be sending the call to the cube. Okay, from the cube, it will be reaching to the another cluster. Okay, then from the another cluster, it will be connecting to the phone. Right? This is what till the phone it's ringing. It's called what? Signaling. Can you see here this one? Signaling here this one. Then you are answering the call. When you are answering the call, see from the IP phone, this traffic is flowing directly to router, not to the CUCM. Why? RTP will not flow via CUCM and it's not mandatory also to flow the RTP via CUCM. Yes or no? Here we have discussed, right? Once it got the source and destination IP address and port number, because RTP is flowing based on the IP address. Okay, it will be looking which is my nearest, how to connect to that destination. So now CUCM is not required, but still CUCM will be monitor that connection. Why? In between, you're terminating the call. Who has to terminate actually that one? CUCM has to be terminated. Or you want to put the call on hold. Who's going to put the call on hold? CUCM. You want to transfer the call. Who's going to transfer that one? Call manager. So RTP will not flow via CUCM, but still CUCM is going to be monitor that call here, this one. Now, in this case, you can see this one. Now, RTP is not going to CUCM. From the IP phone, it's going directly to the cube. From the cube, it will be going directly to the destination phone. Okay. So this is what streaming protocol. Signaling is going IP phone to call manager to gateway, gateway to call manager to the IP phone. This is a signaling. Once the call got established, streaming IP phone to gateway, gateway to IP phone, but it's not going to the CUCM here, this one. So which one is the streaming protocol? RTP here, this one. So now, if the RTP is flowing via your cube router, then it's called media flow through. Media flow through. Obviously, signaling it has to go via cube. There is no doubt on that one. But media, it can be go directly also.
After establishment.
Yeah, if you have any path available, it can be go directly that one. But still the media is flowing via cube. For this, we call media flow through. They'll ask in an interview this one. What is the media flow through and media flow around? Okay. Next, we have media flow around. See if you can see here. This is the phone. It's going to the call manager. From the call manager, it's going to. Sorry. See, from the CUCM gateway to CUCM, CUCM to IP phone. So phone is ringing. It's what? Signaling. Now, once it answer, RTP is establishing directly from this phone to this phone. Now, RTP is not going to queue. That's called flow around. When it is happen, if for example, any other path, any other router is available, then only it happens. You have single router, then there is no option. If there is something public IP addresses you have, there is something connection, ISP, everything, another router, ISP connection you have, then it can flow directly from anywhere. Means it's not flowing via your queue. RTP is flowing via cube, it's called flow through. Okay. If the RTP is not flowing via cube, then flow around maybe, don't know, maybe another path it has taken, but RTP is not coming via gate cube router here. So for this, we can call media flows. Okay, media flow through and media flow around here. This you can be configured on the cube when you are configuring how your media has to be flow. You can be configure that one. Okay, next we have the third one, anti-trombone. Okay, it detects the loop in the media path. What exactly this? For example, I'm having one toll-free number. 1-800-22456, one toll-free number. I'm dialing that number. It's going to the provider. From the provider, okay, let me take it like this. See, this is the gateway, which is actually connected. This is the gateway, which is actually connected to ITSP. I'm having 1-800-22456 number I'm having. If from the outside, someone dialing this number, the call comes to ITSP. From the ITSP, it will be coming, and internally it will be connecting. How you have configured that, what toll-free number, whether it has to be go to the agent or any hunt pilot you have configured, or any CVP, any contact center, any CTA road point, how you have configured, it will be flowing that one. It will be connecting. It will be coming to the call manager. According to that, it flows. What if I am dialing the same number from my internal phone? I'm dialing 1-800-22456. From where I'm dialing? Internal, not from the external. External dialing, it's working fine, no problem. If I'm dialing from the internal, what happened? Again, call goes to the CUCF. It goes to the gateway. From the gateway, it goes to where again? ITSP, right? Because that 1800 is what? External number. It goes to ITSP. Then ITSP, hey, it's your number only. Again, what happened? It will be sending the call to the gateway. So what is happening here? Then again, it will be connecting internally. So this is loop is creating right here. It's generating the call from the same gateway. Again, coming the call to the same gateway. The call also going from the same gateway. Again, from the provider, it's coming back to the same gateway. Then it's a loop, right? So this type of call flow you have, it's going to detect that one, the loops. Then what happened this one? It will not allow to flow the traffic via ITSP. Okay. First time call got established. Then it will be bridge here itself. Locally, it's going to be flow the traffic here, this one. For this, we call it anti-trombone.
But call manager shouldn't send that phone outside.
But actually, 1800 you're dialing. But CUCM doesn't know about 1800 because that's a toll-free number. And the manipulation happen on the gateway. Yes, if you are manipulating the same number 1800 on your call manager, then it will be detected. Getting the point? But here, call manager doesn't know who is this 1800. So that's the reason it will be creating a loop.
Once establishing connection, call manager is down, then also call will go run. Once establishing connection, call manager is down, then also call will be flow or it will disconnect.
So we have on the gateway, depend on the gateways we have, right? We had to be in the MGCP, it's not possible. H.323, it's a possible actually, but by default, it's not possible. We had to configure that one. Okay.
This queue process like signaling is over now, streaming is direct via bypass.
That's the depend. If it is a flow around you have, then it will be work. If it is a flow through, then
gateway. But call manager is on gateway is like that.
Yeah, in this case, it will be work only that active calls.
sir, if we have configured the router as a cube, and now the call should be router outside, sir. If ITSP is down, then what to?
Come again.
We have configured cube for the router and ITSP is down.
Then call will not work, right?
Now, in the production, how it is, sir? They will keep another ITSP or what?
That you can take two connections, redundancy. Same provider, you can take two connection, or two different provider, you can take the two connections. Yeah. Here we have Tata Airtel. Different country, different.
For PSTN also same.
PSTN also we have same. These are the provider, they provide everything. So now Tata is the provider, they provide whatever you want. You want internet, they provide. They want PSTN, they provide. They unlock you want, they provide. Then SIP trunk you want, they provide. Call center setup you want, they provide. IP phone related like CUCM, nothing is required. Everything they provide. Whatever you want, you provide. Security, SD-WAN, what technology you want. Cloud, what technology you want. Everything they provide.
Cloud also there.
Yes. But this front end, back end, they have tied up with a different vendor. For security, SD-WAN, they have tied up with the Fortinet. Okay. And the backend AWS cloud. This is how front end, whatever the service you require, you just go only to the Tata, all the services they'll be for. Got it? This media flow through and media flow around. Minimum this two, you have to remember that is also very simple. Anti trombone. In interview, they are going to be asked. There is a chance what exactly media, how exactly it flows in the cube. They can ask how where that one, but you should know the concept of the media flows here. And the DTMF support. So what is the DTMF when you have a IVR system? If you remember in the IVR system, generally what happened once the RTP got established, if the user gives any input, it will not carry. But in the IVR system, what happened once it established the RTP, if the user gives any input, still it has to be carried the dial digit over the RTP. For that, we have to be configured DTMF support. We have to be configured. So different protocol, different DTMF we have. For example, you are using SIP, different DTMF we have. H.323, different DTMF we have. So here you can see both the end H.323 you have what DTMF you have to support. Both the end SIP you have what DTMF you have to be configured. Means both the end means your gateway and provider. Or one leg is H.323, that is from the gateway to provider, another is the gateway to call manager. So what you have to support. If it is different, what DTMF it has to be support here in this one. This is the chart, defines that. But generally DTMF also will be configuring based on the provider. Because when you have taken the internet connection, what DTMF it has to be configured, will be configuring based on that. Next, the cube configuration, we have voice service wipe, no IP trusted authenticate, mode border element, IP address test list. So these are different commands you have to be execute to configure your cube router. So voice class codec, voice class server groups, then SIP profiles, then few show commands we have. So that's it about the cube here. It's very simple, the cube. IP to IP communication. Okay. The gateway, one end call manager, another end service provider, both end IP address we are using. Then we can be configure this router as a cube. And we have more security here. Okay. It will be hiding the complete information of my internal. Many manipulation we can be done. And what and all the features or services supported by the voice gateway, all the features supported here also on the voice gateway here. Okay, and it support two protocols, SIP and H.323. Any protocol anywhere you can be implement this one. Okay, there is no condition that one always we have to use this. Like for example, MGCP. Whenever if it is connecting to PSTN, then only we have to configure MGCP, right? So in this case, MGCP is not possible to implement. But here, any protocol anywhere you can be use it here. This one for the best practice in the organization, they go with a single protocol. Both the end they go with a single protocol here. Okay, and many organizations they use SIP protocol because H.323 comes into the hexadecimal format. Okay, reading the logs, it will be bit difficult compared to the SIP here. So SIP comes into the clear text. So that's the reason. So always we go with the SIP protocol. Got it? And these are the commands we have to be execute on the ground. Okay, let me show my topology here. Say I'm having a CUCM. Then IP phones are registered. Physical phones, soft phones, we have registered here. And it will be having the extension 6012002, 6012002. This is how 6012003. This is how we have the internal extension. Now I'm going to connect to the router. That's the gateway. And this gateway is connecting to the ITSP. But actually here also I'm using one router. Okay. Now, what's my IP address? CUCM IP address 142.100.64.51. And here the router IP address is 201. Okay. And the ITSP IP address is 202 here. This I'm having here this one. The 201 for the router, 202 for the ITSP I'm having here this one. Now between the CUCM to the gateway, I'm going to implement SIP protocol. Between the gateway to ITSP also I'm going to use SIP protocol here. Then both then it's IP to IP, and this will be configured as a cube here. Cisco Unified Borderline. But actually what happened, this is my lab scenario. Between this router to router, I don't have any serial connection. I have taken one switch. It has connected both on the LAN here. Actual connectivity I'm explaining here. But in the production, what happened? See, here you get different IP address, and here you get different IP address. This IP address differently to connect your CUCM. This IP address connectly to ITS.
We can use their Ethernet port because we have 2 ports.
Yes, you can use it for that one. 2 different ports you can use it, but as if now I don't have the setup like that.
So we're having also 2 ports in one router.
Yes, extra cable we can be connect. We can be doing that. Okay, and binding here in my PPT, if you can see, binding it has done globally, but you should not do the binding globally. You'd have to do it under the dial peer level, that binding. Yeah. So that's how the topology we have. I'll just go very quickly. I'll go to the call manager, app, GUI,
Admin GUI.
admin GUI.
CCI voice 1.
So in this, made the IMP server.
IMP server. What IMP server?
IMP server installation configuration everything. We have done in this call manager or what?
I don't know what you are asking. Is it related to anything SIP?
No, sir.
So now we are doing SIP class. Device, trunk. We have to configure SIP as a same. The SIP last class SIP trunk I have not shown, right? This is the same thing. Okay. Trunk we have to be configured. So fine. Let's see if there is any trunk we have configured. So we don't have any trunk. Add new. Trunk type, SIP trunk. Device protocol automatically SIP. Trunk service type. This SIP trunk you are creating for what? I'll go with the none. Not for CCD, extension mobility, cross cluster, media engine or ISC, nothing here. This one, these are different features. You can be configure the SIP trunk, but now default I'm selecting here this one. Whenever you want to be configure the SIP trunk for the gateway, always you go with the default here this one. Okay, then device name, whatever the name you want, you can be provide here this one. So name is what? Example HQ. Okay, HQ cube. Then description. Headquarter cube. Something trunk I'm giving. Okay. Then device pool. Okay. Where is this office? Under which location? That device pool you have to be select. Now it's in a headquarter here. Then to scroll down. PSTN access, check this one because we require for external access. Run on all active CM nodes. Why? Because I'm configuring where this on publisher. But how many CM call managers are there? Everyone should be aware, right? So that's the reason we have to be check this one. If you are not checking this one, calls will not go. Okay. Then very basically you can configure. Here, your gateway address. What is the gateway? 142.164.201. Like this, you have multiple, you can add the multiple gateway. You can click on the plus, you can add the multiple gateway. So then, since it's a SIP protocol, SIP trunk, automatically the port it has selected 5060 here, this one. Okay, then after you have to configure SIP profile, standard SIP profile. Then SIP trunk security profile we require. Non-secure SIP trunk profile, by default we will be getting select, save this one. That's it.
Sir, if we add multiple routers, IP address there, then will it create multiple SIP trunks or the same only it will be added?
Which one?
That routers IP address.
It will be display here, multiple list it will be display. Actually, it's a single SIP trunk. It's a single trunk, but it will be displayed in the list. Okay, that's it, the configuration under the SIP. Now I'll just jump to my 201 gateway. Let me check it out. Do we have any old configuration in this one? If we have, then we have to remove that one. Oh, we are using this as a MGCP gateway, right? I'm going to delete this. Okay. So now show IP interface brief here. This is what the IP address we have, right? Ethernet, gigabit Ethernet 0/0. Now, as per the configuration, how we have the configuration here. So this one. This is the configuration we have to do. This is the configuration we have to do here. This one. Okay. What I'm going to do here, configure terminal, voice, service, void. Right? Then in this one, can you see this one? This one, IP trusted list. You have to be mentioned first. Then you have to give the IPv4 and IP address. In production, it's a mandatory. We have to configure this one. Which one? IP address, trusted list, and which IP address it has to be trusted. Here, you have to provide your call manager IP address and the provider IP address. This we are configuring for security reason. There is an attack, DDoS attack we have.
DDoS.
TDOS, not DDoS, TDOS attack. We have this one. Okay, someone is trying to attack your network with a different IP address when they are coming. So it will be check it out in the trust list. Okay, which IP address is coming. If it is IP address is coming, which is not listed in the trust list, it's not going to accept anything. It's not going to accept anything. Something the traffic is coming, it's not going to respond to that traffic here for security reason here. So that's the reason we have to configure this one IP trusted list. And here you have to be provide the individually all the IP address of your call manager as well as the provider. Provider, what and all the IP address they have provided, that IP address, there is BC, gateway, media. Sometimes they'll give 2-3 IP addresses. All the 2-3 IP addresses you have to be update under the trusted list here, this one. Okay. So then after you have to be no IP address trusted authenticate. This command you can be execute. Suppose you don't want to authenticate. Any device is come and you want to be accept that call, then you can be execute this one. Now here I'm going to be use this command. No IP address trusted authenticate. No IP address unrecognized. Converting to mode. Let it be this one. I'll go straight to this one. Allow connection. SIP to SIP. 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 Suppose you want to be allow head.323 SIP. Same thing you can repeat. SIP to head.323, head.323 SIP. Everything you want to be configured, you can be enabled. Okay, now the bind control you can be go. Bind control source interface gigabit Ethernet. Why it's not taking? (0/0).
Command bigger detection at 0/0.
See, whenever here it's detecting means bind command itself it's not supporting here. Find SIP, it's supporting the SIP. Okay, sorry. I had to execute that bind command under the SIP. Not there. Bind. So it will be getting control and media. So I'll just first go with the control. Source interface, gigabit Ethernet 0/0. Then again, bind media source interface, gigabit Ethernet 0/0. See, I had to execute this binding command under the SIP. Okay, so IP trusted list, if you want to be configured, you can be configure the IP trusted list also. IP. Okay, but I have to be exit from here because already I'm in a SIP. But that I have to configure under the voice service VoIP. IP. It's not supporting this command. Anyhow, so now if you go to the running configuration, the show voice service VoIP, this is what voice service VoIP. We are allowing the SIP to SIP. Under the SIP, we are binding this interface here. Okay. Next, I'm configuring whenever you're creating a dial pair, you can configure the codec. Okay. One dial pair, you can be configure only one codec. Means when you have configured the wipe, by default, what dial pair you have? Which codec it uses? G.711 codec it uses. If you have a wipe dial pair, okay, wipe dial pair. Here you can configure whatever the codec you want. But in the POTS dial pair, it's not possible to configure the codec. And whenever you're creating a dial pair, one dial pair, only one codec we can configure. But sometimes we have to be configure multiple codecs. How we can configure multiple codecs from one dial pair? So that can be configured by using the voice class. Can you see this one? Voice class codec. One, that's the tag number. Anything you can give here this one. For example, voice class codec. See, this is the tag number. 10,000 we have this one. I'm giving 1. Okay. Then this is the command. Codec preference you can give. Codec preference G711. Yeah. Okay. I have to give the preference 1 G711 ELA. First preference I'm giving G.711 ELA. Next I'm giving second preference EULA. Next I'm going to be provide third preference G729. Okay. Okay, 729 BR8 or R8 we have. This is telling that one. It required more DSP resources because this is the high density codec here, this one. Okay, then we required R8. So this is how what happened here. Now you can see that one under the voice class codec we have created. Under this one we have defined all the codecs. Okay. Now whenever you are creating a dial pair, you associate this voice class codec to the dial pair. Now it can be it will be support these 3 codecs. But directly one dial pair, only one codec it's possible to be configured. It's not possible to configure multiple codecs in a one dial pair. Okay, so just a minute, guys. Give me 2 minutes. Okay, that's the one. And another thing, server group. Whenever if the call is coming from the provider and it's hitting gateway. From the gateway, internally, how many servers you have? CUCM? 3 servers you have because phone can be registered. It may have many servers, but minimum 3. For example, my primary server is down. My phone is registered under the secondary server. Now, how gateway comes to know that one? Now the phone is registered on the secondary. Now I have to send the call to the second CUCM server.
Hello, header something.
Hello messages, that is the between the IP port to CUCM. Now I'm talking about the gateway to CUCM, how gateway understands.
So which server is active, but I keep on get registered.
How gateway comes to know which server is active?
Because it seems and send people in the
To whom?
for gateway.
No. Why CUCM has to send the keep alert to gateway? That is only for the SIP trunk status. To know only the SIP trunk status if you have enabled the SIP options. SIPing messages. So then you have to create a dial peer, right? To send the call from the gateway to CUCM, how the call goes from the gateway to CUCM? Dial peer. What type of dial peer? Wipe dial peer. So when the wipe dial peer, who is the session target? Call manager. Okay. So 3 dial peers you have to create here. Primary, secondary, tertiary, preference you have to give. 1, 2, 3. Always first preference for the primary. If it is not available, then secondary. If it is not available, tertiary. Now, instead of creating a multiple dial peer, single dial peer you want to be create, and the call has to go to all the 3 call managers. 3 means first it goes to the primary. If it is not available, then it goes to secondary. If it is not available, tertiary. For that, we have to configure server group. So voice class server group. Okay. Voice class. Okay, it's not supporting the command. Unfortunately, it's not supporting the command here. Voice class server group. Why it's not supporting? This is the generation 1 router I'm using 2800. If it was a 2900 series, it will support all these things. So see, many commands is not supporting this. Okay, anyhow, so that we have. Then after you have to create a SIP profile. What is that SIP profile? I'll be explain later that one. Then after you have to create only the LPS. Inbound LPS, outbound LPS. Inbound LPS, outbound LPS you have to be created. If you create this much, that's it. On the gateway. LPS you have to create. Okay, then it will be working as usual. That's it, the configuration. Unfortunately, I'm using an old router here, 2800 series. So many commands is not supporting here. So that's the reason I'm unable to show and execute and everything. But when you do the lab, you use that router and do the practice, and it will be support that. Okay, only for the command purpose here. And actually, the real time something you wanted. So I'm going to show you on my real time lab. My company, the how gateway we have configured and everything, and I'll be providing that. And if you want document of that one, the configuration files, that also I'll be providing on that. So, but unfortunately, we are unable to do it. We'll see that one. What other things we can be doing on that one. So based on that, let me see voice class SIP profile it supports. Maybe it supports. Yes, SIP profile it supports. But the voice class server group is not possible. Then individually you have to be configured here. So I'll just save this configuration and I'll keep it. Then the rest of other things will continue from tomorrow. That's the dial peer configuration. Okay, then doing the test call. That's it, that cube. See, generally there is no any cube command, nothing. Voice service VoIP, and you allow connection that one. So it will be, that's only the configuration. This is what voice service VoIP we have, and we have a different command here. One, allow connection we have. This we have to be enabled. Then you can allow the media actually here. That's it. But if you go with the generation 2 and generation 4, more command it supports. How that command, what we have configured and everything, I'll show you that one. And also I'll give one sample. You just keep it. In every company, you are not going to configure this voice gateway, but you just keep it that one. And the reference, I'll explain you that one. So if required, you want to be configured the gateway, just copy paste that. That's enough. Okay, so I'll just save this one, but don't change anything on this gateway, whatever I have removed, something that one. So we can see on that one. So that's it for today. Tomorrow we'll go with